Biography of Albert Einstein, the genius who changed physics forever. Imagine a world without GPS, nuclear energy, or even the modern understanding of the universe itself. Without Albert Einstein's theories, much of today's technology and scientific knowledge would simply not exist. Einstein was not just a physicist, he was the man who redefined time, space, and energy. Born in Germany in 1879, he grew from a curious child who spoke late into the most recognized scientist of the 20th century. From the humble desk of a patent office in Switzerland, Einstein unleashed ideas that transformed physics forever, culminating in his famous equation E equals mc squared. His brilliance, courage to challenge established thinking, and tireless pursuit of truth made him one of the greatest minds in human history. I'm Alessio. This is BioExplainer. If you enjoy history explained clearly and without fluff, subscribe and hit the bell. Leave your like now, because by the end, you'll forget. Let's begin. How could one man, working alone in a small patent office, change our understanding of the entire universe? Chapter 1, Birth and Childhood in Ulm and Munich. // Albert Einstein was born on March 14, 1879. The city was Ulm, in the Kingdom of Württemberg, part of the German Empire. Ulm was small, with medieval roots, located near the Danube River. His birth occurred in a middle-class household. His father, Hermann Einstein, was an ambitious engineer and businessman. His mother, Pauline Koch, was a homemaker and an amateur musician who valued education and culture. The family was Jewish, though not strictly religious. Their identity was more cultural than religious. They lived in a modest but respectable environment. Music filled the home, and Pauline made sure her son learned violin. Hermann and his brother Jacob managed a company that dealt with electrical equipment, including direct current devices. When Albert was still a baby, the family relocated. They moved to Munich, an expanding industrial city in Bavaria. Hermann wanted to pursue better business opportunities there. The city was larger, more modern, and promised economic growth. As a child, Albert did not seem extraordinary. In fact, his early development caused worry. He began speaking later than most children. Family stories said he was silent until the age of 4. This delay led his parents to think something was wrong. Yet, when he spoke, he surprised them with full sentences. He showed signs of curiosity and stubbornness early on. He liked puzzles, mechanical objects, and solitary play. His temperament was quiet, even shy. Teachers sometimes mistook his silence for a lack of intelligence. But in reality, he was thinking deeply, observing quietly. His first exposures to science came from his father and uncle. Hermann and Jacob often brought home equipment from their electrical company. One day, his father gave him a simple compass. The boy became fascinated. The needle always pointed north, even when he turned the object. He wondered what invisible force guided it. That mystery stayed in his mind. His uncle Jacob, an engineer, encouraged him further. He introduced Albert to geometry. At the age of 12, the boy worked through books far ahead of his school curriculum. He called Euclidean geometry holy. It became a foundation for his thinking. Numbers and shapes spoke to him with clarity. Albert's health as a child was delicate. He suffered from fevers and stomach pains. Yet he loved to walk outdoors, exploring nature around Munich. He preferred observing the sky, rivers, and animals to noisy play with other children. He often seemed lost in thought. His family provided comfort but faced challenges. Business did not always succeed. Still, Hermann and Pauline encouraged his education. Pauline insisted on music lessons. Albert resisted practicing but later credited music for sharpening his mind. The violin became his lifelong companion. By the time he reached school age, he had already developed traits that would define him. Quiet observation, independent thought, a fascination with invisible forces. His curiosity extended beyond ordinary childhood interests. He asked questions few adults could answer. In Munich, the foundations of his character and intellect were forming. But his journey had just begun. His years in school would bring both conflict and growth. His restless mind was not easily confined to rigid classrooms. His search for knowledge would clash with traditional authority. And soon, His family's fortunes would change again. But what would happen when the silent, curious boy entered the strict German school system? What awaited him in those classrooms would shape the path of a genius. Chapter 2: Early Education and Growing Curiosity // Albert began school in Munich. He was enrolled in a Catholic elementary school. The environment was strict and disciplined. Teachers demanded obedience. Lessons were repetitive and memorized. For a young boy who loved to think freely, this was frustrating. Despite the rigidity, Albert excelled in certain areas. He showed early brilliance in mathematics. Numbers came naturally to him. He enjoyed solving problems faster than his classmates. His ability to visualize concepts impressed some teachers, but others dismissed him as unfocused. Outside the classroom, his interests grew. He devoured books on science. He borrowed texts meant for older students. Geometry fascinated him. He solved complex problems on his own. By the age of 12, he mastered advanced mathematics far beyond his grade level. His self-directed learning became a pattern for life. The young Einstein was not a typical student. He questioned authority. He challenged teachers when he thought they were wrong. This behavior was unusual for the time. In late 19th century Germany, classrooms followed a military style of order. Students were expected to obey without question. Albert's independent spirit clashed with that culture. His family noticed his unhappiness. He often complained about school. He preferred to study what he loved at home. His mother Pauline encouraged his music. His father Hermann provided books. His uncle Jacob gave him challenging problems. Together, they nurtured his curiosity. Albert also began reading popular science literature. He studied works by Aaron Bernstein, who wrote about natural phenomena. Bernstein's books presented the universe as vast and mysterious. Albert's imagination soared. He pictured himself riding alongside a beam of light. What would it look like? How would time and space behave? These questions would one day form the heart of his theories. But there were struggles. His family faced financial difficulties. Hermann's electrical company began to fail. Contracts were lost. Competition was fierce. By the mid-1890s, the family business collapsed. This forced decisions that changed Albert's path. The Einstein family left Munich and moved to Italy. They settled first in Milan, then in Pavia. Hermann sought new opportunities in electrical engineering. Albert stayed behind temporarily to complete his studies. He was left alone in Munich, living in a boarding house. At just 15, he faced isolation and unhappiness. In school, his situation worsened. He grew more rebellious. His teachers accused him of arrogance. One even told him he would never amount to anything. The young Einstein felt stifled. Finally, he left school without completing his diploma. He reunited with his family in Italy. Despite the disruption, his curiosity never stopped. In Italy, he enjoyed long walks and new surroundings. He continued independent studies in mathematics and physics. He read works by great scientists like Maxwell and Newton. These readings shaped his early understanding of the laws of nature. But to move forward, he needed formal credentials. He wanted to enter higher education. Switzerland offered an opportunity. The Swiss education system was less rigid than the German model. Albert applied to the Swiss Federal Polytechnic in Zurich, a respected institution. He was only 16 at the time. He took the entrance exam in 1895. His performance was mixed. He excelled in math and physics, scoring far above the requirements. But in subjects like languages and history, he struggled. The school rejected his application. Still, he did not give up. The examiners recognized his extraordinary talent in science. They advised him to complete secondary studies at a Swiss school. He enrolled at the Cantonal School in Aarau, Switzerland. There, the atmosphere was different. Teachers encouraged independent thinking. Albert thrived. In Aarau, he began to develop the habit of questioning accepted truths. He studied not just for exams, but for understanding. He imagined experiments in his mind. Could time slow down? Could space bend? His questions were bold. His ideas were original. By 1896, Albert earned his diploma from Aarau. He was now prepared to reapply to the Polytechnic in Zurich. His journey from a struggling, rebellious student in Germany to a promising young scholar in Switzerland was complete. But this was only the beginning. Ahead lay the challenges of student life, friendships, and the discovery of love. His years in Zurich would shape not only his career but also his personal life. And soon, he would meet someone who would play a pivotal role in both. Chapter 3. Move to Switzerland and Student Years at Zurich Polytechnic. // Albert Einstein's move to Switzerland marked a turning point. In 1896, at the age of 17, he entered the Swiss Federal Polytechnic in Zurich. The institution later became the ETH Zurich. It was one of Europe's leading schools for science and technology. Admission was highly competitive, but Einstein's brilliance in physics and mathematics secured his place. The atmosphere in Zurich was unlike Germany. The school encouraged debate and independent thinking. Professors valued creativity. Students came from across Europe, bringing new ideas and perspectives. Einstein thrived in this environment. He was assigned to the section for teachers of mathematics and physics. The program prepared students to become instructors. But Einstein had little interest in teaching. His passion was discovery. He wanted to understand the laws of nature at their deepest level. At the Polytechnic, Einstein formed important friendships. One was with Marcel Grossmann, a fellow student who later became a professor of mathematics. Grossmann was organized and disciplined, the opposite of Einstein's scattered style. He often lent Albert his carefully written notes, which helped him pass exams. Einstein also joined lively discussions with other classmates. They debated physics, philosophy, and literature. Zurich was a city of ideas, full of cafes where students argued late into the night. These conversations sharpened his thinking. During this time, Einstein met Mileva Maric. She was the only woman in his class. Born in Serbia, Mileva was highly intelligent and determined. She and Albert quickly formed a close bond. They studied together, exchanging thoughts on physics. Their relationship grew into romance. Mileva would later become his first wife. Despite his intellectual strength, Einstein often clashed with professors. He skipped lectures he found dull. He preferred to study independently. Some teachers resented his disregard for authority. One professor, Heinrich Weber, disliked him so much that he later refused to write recommendations for him. This strained relationship would cause difficulties after graduation. Einstein's student life was not easy. He struggled with finances. His parents, still in Italy, could not fully support him. At times, he relied on small tutoring jobs. Yet, he remained focused on his studies. He spent long hours working through physics problems and reading beyond the curriculum. In 1900, at 21 years old, Einstein graduated. He received a teaching diploma in mathematics and physics. His grades were not the highest, but his professors recognized his talent. He was qualified to seek work as a secondary school teacher. Still, the path ahead was uncertain. Jobs were scarce, and Einstein's lack of diplomacy with professors left him with few recommendations. His brilliance was clear, but opportunities did not come easily. At the same time, his relationship with Mileva deepened. They faced challenges. Mileva became pregnant before marriage, a scandal in conservative Europe. Their first daughter, Lieserl, was born in 1902. Her fate remains unclear, with historians divided on whether she died young or was given up for adoption. As Einstein left the Polytechnic, he carried both promise and struggle. He was brilliant but unemployed, independent but isolated, in love, yet facing personal challenges. He had the diploma but no job. What would happen to this restless young graduate? How could he turn his talent into a career? The answer lay in an unexpected place, a desk at the Swiss Patent Office. What he would do there would change science forever. Chapter 4. Personal Struggles and the Patent Office Years in Bern. // After graduation in 1900, Albert Einstein faced disappointment. Teaching positions were scarce. His professors, irritated by his defiance, refused to recommend him. Without support, he struggled to find work. For nearly 2 years, he moved between temporary tutoring jobs. He worked as a substitute teacher in small towns. The pay was poor, and the instability weighed on him. At the same time, his relationship with Mileva Maric brought both comfort and stress. They wanted to build a future together, but financial insecurity made marriage impossible. When Mileva became pregnant in 1902, their situation grew even more complicated. Their daughter, Liesl, was born in Serbia. Historians still debate her fate. Some suggest she died from illness, others believe she was given up for adoption. Einstein rarely spoke of her, and she vanished from official records. That same year, Albert's father, Hermann Einstein, passed away. His death left Albert grieving but also determined to secure stability. Relief came from an unexpected source. A former classmate, Marcel Grossmann, recommended him for a position at the Swiss Patent Office in Bern. In 1902, Einstein began work as a technical expert, third class. The job involved evaluating patent applications for electrical devices. He examined designs for generators, motors, and instruments. The work was repetitive but demanded precision. Einstein approached it with discipline. The office hours were fixed, leaving evenings and weekends free. This stability changed his life. With a steady income, he could finally marry Mileva in 1903. They lived modestly in Bern, in small rented apartments. Their first son, Hans Albert, was born in 1904. Their second, Eduard, would arrive in 1910. Family life brought joy but also challenges, as money remained tight. At the patent office, Einstein's mind was rarely idle. He analyzed inventions by day, but by night, he pursued his own ideas. Surrounded by stacks of papers, he scribbled notes on theoretical physics. He filled notebooks with equations. His curiosity burned stronger than ever. In Bern, he also formed a circle of intellectual friends. They called themselves the Olympia Academy. The group included Maurice Solovine and Conrad Habicht. They met in apartments and cafes. Together, they read and debated works by great thinkers: Hume, Poincaré, Mach, Spinoza. The discussions ranged from philosophy to science, always pushing Einstein's imagination. He began publishing papers in scientific journals. His early works dealt with molecular forces and thermodynamics. They attracted modest attention but revealed his talent. He was still unknown outside small academic circles. Yet, something extraordinary was forming in his mind. By 1905, Einstein was 26 years old. He was still a patent clerk, earning a modest salary. He had no academic position. His professors had dismissed him as average. Few imagined he could achieve greatness. But behind the quiet walls of the patent office, his thoughts were breaking boundaries. He was about to unleash a series of ideas that would transform physics. The year 1905 would later be called his Annus Mirabilis, his miracle year. And what he produced in that single year would shock the scientific world. Chapter 5: The Annus Mirabilis and Breakthroughs in Physics. The year was 1905. Albert Einstein was still working as a clerk in the Swiss Patent Office. He was 26 years old, living modestly with his wife Mileva and their young son. On the surface, nothing suggested greatness. He had no university post, no laboratory, no staff. Yet in that year, he produced 4 papers that shook the foundations of science. The first paper explained the photoelectric effect. Physicists had noticed that light could knock electrons off a metal surface. But classical theory could not explain why. Einstein proposed that light behaved not only as a wave but also as discrete packets of energy, later called photons. This radical idea suggested that light had a dual nature. It also laid the groundwork for quantum theory. Without it, modern technologies like solar panels, digital cameras, and lasers would not exist. The second paper dealt with Brownian motion. Tiny particles suspended in liquid seemed to move randomly. Some dismissed this as a quirk. Einstein showed it was caused by invisible collisions with molecules. His analysis provided evidence for the atomic theory of matter, convincing skeptics that atoms were real. This strengthened the foundations of chemistry and physics. The third paper introduced the special theory of relativity. It challenged ideas that had stood since Isaac Newton. Einstein argued that space and time were not absolute. They depended on the observer's motion. He showed that the speed of light was constant for all observers, no matter how fast they moved. This meant that time could slow down, and lengths could contract, depending on speed. It was a shocking new vision of reality. The fourth paper, a short note, contained a simple but profound equation: E equals mc squared. Energy equals mass times the speed of light squared. This meant mass and energy were interchangeable. A small amount of mass could become immense energy. The concept would later lead to nuclear power and weapons. At the time, it revealed a deep unity in nature. All four papers were published in Annalen der Physik, a respected German journal. Few noticed immediately. Einstein was still unknown, a patent clerk writing in his spare time. But leading physicists soon realized the importance. Max Planck, one of the most influential scientists of the era, recognized the brilliance. He began to correspond with Einstein. Recognition spread slowly but steadily. Einstein's Annus Mirabilis, or Miracle Year, marked his entry into history. In one burst of creativity, he redefined light, matter, time, and energy. Few individuals have ever transformed science so profoundly in such a short period. Even as these ideas circulated, Einstein remained in his modest position. He still walked daily to the patent office. He still lived in small apartments with his family. He was not yet famous. But the seeds of revolution were planted. By 1908, his reputation had grown. Universities began to take notice. Offers of teaching positions finally arrived. He left the patent office for an academic career. His journey from obscure clerk to scientific pioneer was complete. Yet his work was not finished. He had explained motion at constant speed. But what about acceleration? What about gravity? His restless mind pushed forward. He wanted to expand relativity into a grander theory. The next decade would demand his full energy. It would test his patience, his health, and even his marriage. But what emerged would change how humanity understood the universe itself. Chapter 6: Academic Success and the General Theory of Relativity. By 1909, Albert Einstein left the patent office behind. He accepted a position as a lecturer at the University of Zurich. At last, he entered academia. Recognition was growing. His earlier papers were now widely discussed. Students flocked to his lectures, curious about the man who dared to redefine space and time. In Zurich, he worked intensely. But soon, better opportunities appeared. He became a professor in Prague in 1911, then returned to Zurich in 1912. By 1914, he received an invitation to Berlin. There he joined the Prussian Academy of Sciences, one of the most prestigious institutions in Europe. Berlin also brought him closer to scientific circles where his ideas could expand further. Yet his personal life grew complicated. His marriage to Mileva Maric was strained. Financial stress, emotional distance, and Albert's relentless focus on physics weakened their bond. The separation became final, and in 1919, they divorced. Later that same year, Einstein married Elsa Lowenthal, his cousin, who provided stability and companionship. His scientific mission during these years was immense. He wanted to extend the special theory of relativity. Special relativity described objects moving at constant speeds. But it did not address acceleration or gravity. Einstein believed a deeper law governed the universe. He spent nearly a decade searching for it. The breakthrough came in 1915. After years of calculations, errors, and revisions, Einstein presented the general theory of relativity. It was elegant, bold, and revolutionary. The theory argued that gravity was not a force pulling objects, as Newton had described. Instead, gravity was the warping of space and time by mass and energy. Planets orbited the sun not because of an invisible pull, but because the sun bent the fabric of space around it. The theory was radical, but how could it be tested? Einstein proposed a prediction. During a solar eclipse, the sun's gravity should bend the light of distant stars. If astronomers photographed stars near the sun during an eclipse, the stars would appear slightly shifted. It was a bold test. In 1919, 2 British expeditions set out to confirm the prediction. One group, led by Arthur Eddington, observed the eclipse from the island of Principe, off the coast of Africa. The other worked in Brazil. Despite difficult weather, the results confirmed Einstein's theory. Light indeed bent as predicted. The announcement made headlines worldwide. Newspapers declared Einstein a genius who had overturned Newton. Suddenly, he was a global celebrity. In an age still recovering from World War I, his rise had symbolic power. A German Jewish scientist, confirmed by British astronomers, became a figure of reconciliation and progress. His fame spread beyond science. He was invited to lecture across Europe and the United States. Crowds filled auditoriums to hear him. Journalists chased him in the streets. He became an icon of intellect, instantly recognizable with his wild hair and pipe. But fame came with pressure. His life grew more public. Letters and requests poured in daily. Politicians, artists, and leaders sought his opinion. Some admired him as a symbol of human brilliance. Others criticized him, calling his theories incomprehensible or even unpatriotic. Despite the chaos, Einstein continued his work. He corresponded with scientists worldwide, refining relativity and exploring new ideas. But the general theory of relativity had already secured his place in history. The boy once dismissed as a poor student had redefined the cosmos. Space and time were no longer rigid. Gravity was no longer a simple pull. The universe had become a dynamic, flexible fabric, shaped by matter and energy. Yet Einstein's journey did not stop with relativity. In 1921, a new recognition awaited him. It was not for relativity, but for an earlier idea, one that had launched quantum theory. And that recognition would make him not only a famous scientist, but also a Nobel laureate. Chapter 7, Nobel Prize and Global Influence. // In 1921, Albert Einstein received the Nobel Prize in Physics. To the surprise of many, it was not awarded for his theories of relativity. Instead, the prize honored his explanation of the photoelectric effect, published in 1905. The committee considered relativity too radical at the time. But the photoelectric effect had clear experimental proof, and its importance was undeniable. The Nobel Prize brought Einstein new prestige. He was already famous in newspapers, but now he was officially recognized as one of the greatest minds of his era. Invitations arrived from across the globe. Universities, governments, and scientific academies wanted him to lecture. He began to travel frequently, becoming a truly international figure. His first major trip after the award was to the United States in 1921. He visited New York, Princeton, and Washington, D.C. Crowds gathered at the docks when his ship arrived. Reporters chased him through the streets. Americans were fascinated by this modest man with unkempt hair, who seemed uninterested in fame but carried the secrets of the universe in his mind. Einstein's impressions of the United States were mixed. He admired the openness and energy of American culture. He also noticed its growing industrial and scientific power. But he was struck by inequality. On later visits, he spoke against racial segregation, expressing solidarity with African American communities. He saw racism in America as a profound injustice. During the 1920s, Einstein traveled even further. He visited France, England, Spain, and Japan. In Japan, he was welcomed like a head of state. Thousands gathered to see him. In Palestine, he visited Jewish communities and spoke about the future of a homeland for Jews. His support for Zionism grew stronger. Beyond science, Einstein's voice carried weight in political and social debates. He was outspoken against militarism and nationalism. World War I had left Europe shattered, and Einstein believed peace and cooperation were essential for survival. He signed petitions, gave speeches, and used his fame to call for disarmament. His activism earned both admiration and criticism. Some hailed him as a moral leader, a scientist with conscience. Others accused him of interfering in politics. In Germany, right-wing groups targeted him, denouncing his theories and his Jewish heritage. Newspapers published attacks against him. He received death threats. Despite the hostility, Einstein continued his work. He collaborated with leading physicists of the time, including Niels Bohr and Max Planck. Together, they laid the foundation for quantum theory. But here, Einstein's role became complex. His early work supported the birth of quantum physics. Yet as the theory developed, he grew skeptical. Quantum mechanics introduced the idea that particles behaved unpredictably, governed by probabilities. For Einstein, this was troubling. He believed the universe followed deeper laws. He famously remarked, "God does not play dice with the universe." This phrase reflected his resistance to the randomness of quantum theory. His debates with Bohr became legendary, shaping the course of physics for decades. During these years, Einstein balanced his roles. He was a researcher, a public intellectual, a traveler, and an activist. His name was known everywhere. His image appeared in magazines, cartoons, and even advertisements. He became a symbol of genius, often compared to cultural icons. But fame came with exhaustion. His personal life was often under strain. His marriage to Elsa provided some stability, but the demands of public life weighed heavily. He longed for quiet moments to think, to return to the solitude he once enjoyed in Bern. Still, the world refused to let him retreat. As the 1930s approached, the political climate in Germany darkened. The rise of extremism threatened not only his work but his very existence. The scientist who had explained the universe now faced the harsh realities of a collapsing society. And soon, he would be forced to make a decision that would change his life forever. Chapter 8: Rise of Nazism and Exile to the United States. The late 1920s and early 1930s brought dramatic changes to Germany. The Weimar Republic, fragile from the start, faced economic crisis. Hyperinflation, unemployment, and political unrest shook society. In this environment, extremist movements gained strength. Among them was Adolf Hitler's National Socialist Party. For Einstein, the situation became increasingly dangerous. He was a Jew, a public intellectual, and a critic of nationalism. His fame made him an easy target. Right-wing newspapers published attacks against him. They called his theory of relativity Jewish physics. Posters and pamphlets denounced him as a fraud. The threats were not only rhetorical. In 1922, his colleague Walther Rathenau, also Jewish, was assassinated by extremists. Einstein began to fear for his safety. Despite the hostility, Einstein continued to speak openly. He warned against the rise of fascism. He urged resistance to hate and violence. His moral courage stood out, but it also increased the danger. By 1932, the situation had reached a breaking point. In January 1933, Hitler became Chancellor of Germany. Within weeks, the Nazi regime began persecuting Jews and silencing critics. Einstein, who was traveling in the United States at the time, realized he could never return. He resigned from the Prussian Academy of Sciences and declared that he would not live in a country ruled by hate. His home in Germany was raided. His property was seized. His name appeared on Nazi death lists. Exile was difficult but necessary. Einstein accepted a position at the newly established Institute for Advanced Study in Princeton, New Jersey. In October 1933, he sailed to America with his wife Elsa. Crowds of journalists and admirers greeted him when he arrived. For Americans, Einstein was already a legend. Princeton offered him safety and stability. The institute allowed him to focus entirely on research without teaching duties. He settled into a modest house on Mercer Street, where he lived the rest of his life. In the United States, Einstein also found a new role as a public intellectual. He became a symbol of freedom and the pursuit of knowledge. But his heart was heavy. He had left behind colleagues, friends, and family. Many European Jews faced persecution. Some would not survive. Einstein used his fame to help refugees. He raised funds, wrote letters of support, and advocated for Jewish scientists to find positions abroad. He believed it was his duty to act. Even in exile, Einstein could not ignore the growing crisis in Europe. The Nazi regime expanded its power. By the late 1930s, war seemed inevitable. Einstein, once a staunch pacifist, began to reconsider. He feared that Germany might develop powerful new weapons, using the very physics he had helped uncover. In 1939, fellow scientists Leo Szilard and Eugene Wigner approached Einstein. They warned that nuclear fission, recently discovered, could lead to bombs of unimaginable power. Together, they drafted a letter to President Franklin D. Roosevelt. Einstein signed it, urging the U.S. government to accelerate research on nuclear weapons before Germany did. This letter contributed to the creation of the Manhattan Project. Einstein himself never worked directly on the project. He remained at Princeton, continuing theoretical studies. Yet his name was forever linked to nuclear power. He later expressed regret, calling his role indirect but necessary at the time. Exile had transformed him. Once a German citizen, he became an American icon. He admired the freedoms of his new home but criticized its flaws. He spoke against racial segregation and campaigned for civil rights. He supported democracy and condemned authoritarianism in all forms. By the early 1940s, Einstein was firmly established in the United States. His days of wandering were over. But his work was far from finished. At Princeton, he pursued an ambitious dream: to unite all the forces of nature into a single theory. It was a task that consumed his later years. But as he worked in quiet Princeton, the world outside was changing rapidly. War, atomic weapons, and a new age of science redefined humanity's future. And in this final stage of his life, Einstein would become more than a scientist. He would emerge as a philosopher, a voice of conscience, and a symbol of humanity's search for meaning. Chapter 9: Princeton Years and Final Decades. Albert Einstein's final chapter began in Princeton, New Jersey. He settled there in 1933 and remained until his death more than 2 decades later. His home on 112 Mercer Street was modest. Visitors were often surprised. They expected luxury for the world's most famous scientist, but Einstein lived simply. His house was filled with books, papers, and a few personal belongings. He often walked the streets in worn sweaters and sandals, carrying his violin. The Institute for Advanced Study gave him freedom. He had no teaching duties and no classes to run. His only responsibility was to think, to research, and to write. Surrounded by brilliant colleagues, including mathematicians and physicists, Einstein devoted himself to his greatest unfinished goal: the search for a unified field theory. He believed the forces of nature, gravity, electromagnetism, and perhaps more, were different faces of a single reality. Just as Newton had united motion and force, and Einstein himself had united space and time, he hoped to take the final step. But progress was slow. Physics was changing rapidly. The rise of quantum mechanics dominated the field. Young physicists embraced the new approach, while Einstein resisted. He respected the mathematical power of quantum mechanics. Yet he could not accept its randomness. The idea that particles behaved by chance disturbed him. He believed deeper laws remained hidden. His debates with Niels Bohr became legendary. Bohr defended quantum uncertainty, while Einstein insisted on order beneath the chaos. "God does not play dice with the universe," he once remarked. The discussions never reached agreement, but they defined one of the greatest intellectual rivalries of the century. As science moved toward nuclear power and particle physics, Einstein became more isolated. Younger researchers admired him but worked on theories he rejected. Still, his reputation never faded. He remained the symbol of genius, the man who had reshaped the universe. In Princeton, Einstein also became deeply engaged in political and social issues. He had fled fascism, and he saw authoritarianism as the greatest threat to humanity. During World War II, he continued to support refugee scientists and condemned Nazi brutality. After the war, when the United States used atomic bombs on Japan, Einstein was shaken. Though he had only indirectly influenced nuclear research, the connection haunted him. He became a vocal advocate for peace and disarmament. He supported movements against nuclear weapons. He joined the Emergency Committee of Atomic Scientists, warning of global destruction if humanity failed to control its inventions. He wrote articles, gave speeches, and signed petitions. His fame ensured that his words carried weight. Politicians, journalists, and activists turned to him for guidance. Einstein also embraced causes within American society. He supported civil rights leaders and spoke against segregation. He invited African American performers and activists to his home. He saw racism as a poison, not unlike anti-Semitism in Europe. For him, justice was universal. His daily life was simple. He worked in his study most mornings. Papers piled up on his desk. He scribbled equations on scraps of paper. In the afternoons, he often played violin, taking breaks from thought. He walked through Princeton, sometimes alone, sometimes with colleagues. Residents became accustomed to his presence. To them, he was not only a scientist but a neighbor. Visitors from around the world came to see him. Some were scientists seeking advice. Others were politicians, artists, or admirers. Einstein was polite but valued privacy. He disliked ceremony and refused honors that placed him on a pedestal. Yet he understood his symbolic role and used it to promote ideas of peace, democracy, and human dignity. As he aged, his health declined. He suffered from heart problems and increasing fatigue. But he continued to work, filling notebooks with attempts at a unified theory. Even in his final days, he carried papers to the hospital, unwilling to abandon the search. Einstein never saw the unification he dreamed of. But his presence in Princeton left a legacy of wisdom and humility. He had transformed modern science, yet he lived with modesty. He had achieved fame, yet he remained committed to truth above glory. The boy who once puzzled over a compass needle had journeyed far. From Ulm to Munich, from Zurich to Bern, from Berlin to Princeton, he had challenged the world to rethink reality. He had confronted prejudice, exile, and war. And through it all, he had remained faithful to curiosity, justice, and the pursuit of knowledge. The final decades in Princeton revealed Einstein not only as a scientist but as a human being, thoughtful, compassionate, and restless until the end. He had illuminated the cosmos, warned of its dangers, and called humanity to responsibility. And so, the life of Albert Einstein reached its quiet close. A life of questions, struggles, discoveries, and enduring wonder. A life that changed the very fabric of the universe. What did you think of this story? Did it change the way you see time, space, and the power of human imagination to reshape our understanding of the universe? Thank you for watching. Here are 2 more videos you might enjoy. The first is biography of Nikola Tesla, a visionary inventor who rivaled Einstein in imagination. The second is biography of Marie Curie, a pioneer who changed science and medicine forever. See you in the next story.